Okay. Continuing on chapter 4, mass. Right. Now, I'll start with mass first. You can keep your questions to later, okay, after the recording. Mass. Mass is the amount of substance or matter in the body. Okay, and you all know if it's a scalar or a vector? It's a scalar because there's no direction involved. Alright, and the SI unit for mass is in kilogram. Okay, right? Now, the mass of an object, okay, does not change if you bring it from this place to the other place. So, mass remains constant regardless of location. Now, one favorite question that will be asked in an exam is usually, okay, I have a body of 50 kilograms on Earth, right? What happens to this mass when I bring it up to another planet, for example, maybe another place like Earth, Moon? Does the mass change?
Yeah.
No, mass remains constant regardless of location. The mass does not change. Your arm does not become thinner when you go to the Moon. The amount of substance in your body is the same regardless of the location. So please be sure, don't get tricked, alright? And it's measured. Yesterday we went through. It's measured by a beam balance. Okay, and the unit is kilogram. Okay, one key point is you must be able to change the units easily. Okay, from grams to kilograms. These are the two most common ones. Usually megagrams, no, very rare. But you must be able to use the prefix also. Kilo means 10 to the power of 3 grams. Okay, if you are trying to recall. Okay, now let's move on to the next idea where we talk about weight. Okay, weight is the result of the pull of gravity on the body. Okay, weight must be caused by the pull of gravity. If there's no gravity, there's no weight. Right? Now, weight is commonly measured with this formula. It's the product of the mass and the gravitational field strength. So G is the gravitational and what is the value on Earth of G? Approximately 10 meters per second squared. Okay, approximately 10 meters per second squared. Alright, the exact value, okay, changes from country to country, sea level to sea level. Okay, it changes a little bit. The G in Singapore is slightly different, in the G in Africa, in the US is slightly different. Okay, but it does not differ much. Maybe 0.01 or 2, that's all. Alright? So now from this equation, we can all see that weight is dependent on two things, mass and G. Now if the G changes, will the mass change? No. If the G changes, the mass does not change. What changes? The weight changes. Okay? So please be aware. Okay? And weight is measured in newtons because weight is a force. Weight is a force. Weight is a pull by gravity. Do we remember the definition of a force in secondary 1 and 2? A force is either a push or a pull. Alright, so because the gravity is pulling us down, okay, creates the weight, and thus weight is a force. Alright, so actually that's about it. W is mg. Now when you use this formula, please be careful. Your mass must be in what units? Kilograms. Alright, it must be in kilograms. You cannot use this formula with mass being in grams. No, not possible. Right? Let's move on to the last one before we stop for question. Density. Right, density is defined as mass per unit volume. Alright? Typically, in order to remember this relationship, what we have is this. Mass, density, volume. Right? In order to find density, we cover D, we get mass divided by volume. In order to find volume, I cover V, mass divided by density. In order to find mass, I cover M, density multiplied by volume. Okay? Now, density is commonly measured in two forms of units. One is grams per meter cube. Or you write in this form, gram is per cm cube. Or they are the same, I mean these two are the same. It's just a matter of the index. One is negative, one is positive. So depending on the question, okay, if let's say my mass is in grams, alright? My mass is in grams. My volume is in cm cube. Thus, my density must be in. My density must be in grams per cm cube. Now, can you mix and match? For example, can I change the unit to kilogram per cm cube? You can. But in the exam, you are usually given the answer column, right? The answer is how much, right? Now, there's always a unit at the back. Let me show you an example. For example, okay, this is a typo. It should be density. Okay, they give you the unit as such. Alright, you have to work with these units. That means your mass must be in grams and your volume must be in cm. So work around it, alright? Don't be so fixed on one unit. It's not like this, alright? Okay, the last one is on flotation versus sinking. Floating versus sinking. Alright? Oh, sorry. Floating versus sinking. Now what do we know about floating and sinking?